Hi everyone, Miss Robin here, and I am so excited to be here to learn with you today. Can you guess what I love? I do love pizza and puppies, but I really love fractions. Oh, come on now, no moaning and groaning. Fractions are so much fun. In our time together today, we are going to learn about comparing and ordering fractions. What does it mean to compare and order fractions? Wow, you all are exactly right. Comparing fractions is all about figuring out which fraction is larger or smaller, and ordering fractions is when we put them in size order. Now, let's look at some strategies we can use to compare and order fractions. Before we begin with strategies, let's remind ourselves that when we work with fractions, we are always assuming that we are discussing the same size whole, because 1/4 of a large pizza and 1/4 of a small pizza are not the same size fourth. Let's begin by looking at two unit fractions, 1/4 and 1/3. What are some ways we can determine which of these fractions is larger? Ooh, I heard someone say we can draw an area model. That's a great idea. Let's try that. The models show the size of each piece the whole has been divided into. Using the area models, which fraction is larger? Yes, 1/3 is larger. This is very similar to our pizza analogy in the beginning. I heard someone else say we could use a length model to determine which is larger. Let's look at that strategy. Using the length models, which fraction is larger? Yes, the length models also show that 1/3 is larger than 1/4. We can also use a number line to compare fractions. Let's look at this strategy for comparing fractions. First, we need to have an open number line. Since both fractions are smaller than 1, we can start with 0 and stop at 1 whole. Now, how could I partition this number line to show fourths? Exactly. I need to make 4 equal sections and label them. Let's see, 1/4, 2/4, 3/4, and 4/4. Great. Now, let's do the same thing for thirds. So 1/3, 2/3, and 3/3. Looking at the placement of the fraction on the number line, I can see that 1/3 is further from 0 than 1/4, showing that it is larger. Using all these strategies and models, we can see the size of a third is larger than the size of a fourth. What generalization can we make with this information about comparing unit fractions? Yes. I heard lots of explorers talking about how denominator on a unit fraction is important when comparing unit fractions. Let's think about why the denominator is so important. What do you think? I agree. The denominator tells us how many pieces the whole is divided into, and that lets us know the size of each piece. Let's look at some fractions to compare in order. 2/3, 2/4, 2/8, 2/6. We can compare and order these fractions without drawing models by using their denominators as clues to which is largest and which is smallest. In the area and length models, as well as the number line comparing 1/3 and 1/4, we could see that since we are discussing the same size whole, the unit fraction 1/3 is larger because the whole has been divided into less pieces than the unit fraction 1/4. Remember, this strategy is for when the numerators are the same, but denominators are different. Thinking back to our pizzas, this is true because if I have 1/4 of a large pizza, that is less pizza than 1/3 of a large pizza. Let's continue looking at these fractions. We already know that thirds are larger than fourths, so we can order those already. Since both the numerators are 2, it is the same as when the numerators are 1. We have the same number of pieces, so we are using the size of the pieces to determine which fraction is larger or smaller. What do we think about 2/6? We know that a whole cut into 3 equal pieces has larger pieces than that same size whole cut into 4 equal pieces. So what would that mean for 6 equal pieces of the same size whole? Absolutely. The pieces are going to be smaller than both thirds and fourths because there are 6 of them. So what does that mean for 2/8? Using what we know, where would 2/8 go in our order from smallest to largest? Exactly. 2/8 is the smallest fraction we have on the board because 8s are smaller pieces than 6, thirds, or fourths. Let's construct length models for each fraction so that we can see where we are correct in our ordering. Can you draw a length model for each of these fractions? Here is a length model for 2/8, 2/6, 2/4, and 2/3. Using the length models, it is easy to see that the denominator plays a large role in determining the order of fractions when the numerators are the same. What do you notice about the order of the fractions? I agree. The denominator is increasing, but the amount is decreasing. It's the opposite of what happens with whole numbers. I wonder why that would happen. I agree. We can see in the models that as the amount of pieces gets larger, the size of the pieces gets smaller. I like to think of it as sharing a pizza. If I share a pizza with one friend, I will get more pizza than if I share that same pizza with 4 friends. So now we have discussed comparing and ordering with the same numerator, but what about the same denominator? Let's look at 1/4, 3/4, and 2/4. Remember that we assume the whole is the same size. Which of these is largest? Let's try an area model to see what we see. What do you notice? Yes, the pieces are all the same size. So the numerator will decide which fraction is the largest, 3/4. In the middle is 2/4, and the smallest is 1/4. Let's place them on a number line and see if the results are the same. On our open number line, we will start with 0 and end with 1. Now we need to divide the whole into fourths. 1/4, 2/4, 3/4, 4/4. It is easy to see on the number line that 1/4 is the smallest and 3/4 is the biggest. Great job. Okay, our time is almost up for today, so let's summarize what we have learned. Fractions can be compared and ordered based on their denominators if the numerators are the same, because you are dealing with the same number of pieces and it is the size of the pieces that determine which is least and which is greatest. Fractions can also be compared and ordered based on their numerators when their denominators are the same, because when the denominators are the same, the pieces are all the same size. And so the number of pieces determines which is greatest and which is least. Thanks for tuning in with me, Math Explorers.